Okay, good morning again, everyone. Day two. This will be another two-parter here. We'll have two video lessons. So the first video lesson will cover identifying the domain and range of relations. We talked a little bit about this yesterday, but we'll actually see today what makes a relation a function. And so we'll be looking at domain and range and relations, and then whether or not a relation is a function. So yesterday we had some terminology. We had relation, domain, and range, and today we'll add function. So let's look at what we looked at yesterday. A relation is a pairing of input values with output values, x and y. Okay, it can be shown as a set of ordered pairs x and y, where x is an input and y is an output. So yesterday we said x is the domain and y is the range. Okay, today we'll also say that x is the independent variable and then y is the dependent variable. Okay, y depends on x. So x, domain, and independent variable, they all mean the same thing. Y, range, and dependent variable, they all mean the same thing. The set of input values for a relation is called the domain, and the set of output values is called the range. Again, d before r, x before y. X is domain, y is range. Here we have a mapping diagram, which tells us what each x goes to. We only have one x, okay? And that x goes to A, and it goes to B, and it goes to C. So 2 goes to A, 2 goes to B, and 2 goes to C. So notice here, they listed that for us as ordered pairs, okay? In roster notation, because we have a finite number of elements, okay? We have 3 ordered pairs. 2 goes to A, 2 goes to B, and 2 goes to C. Okay, so again, x is the input or the domain, and y is the output or the range. And today we'll also throw in that we could say that x is the dependent variable, independent variable, is the independent variable, and then y is the dependent variable. Y depends on x. Okay. So identifying domain and range. So here we have 5 coordinate points, and let's see here. And so let's identify the domain. Remember, the domain is the x. So x, 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 and x. And so my domain includes 100, it includes 120, it includes 140, it includes 160, and it includes 180. And there they listed that there as a discrete number of elements, 100, 120, 140, 160, and 180. And then the range are the y's. So we have 5 for y, another 5, 6 for y, another 6, and then 12 for y. But when we list those, we only list each element only once, okay? So even though we have 2 5s, we only list it once. Even though we have 2 6s, we only list it once. And then we have 1 12. So my range, which are the y's, is 5, 6, and 12. We do not list duplicates, never. We don't list duplicates. So in this coordinate plane here, we have 1, 2, 3, 6 coordinate points, right? And so I'm sure you know how to graph coordinate points. So this is -2 and 2, and then I'll just graph another one just for you to recall. This is 3 and -3. So our domain are the x's. That would be -2, -1, 0, 1, 2, and 3, which they list down there. That's our domain. And our range we have for y 2, 1, 0, -1, -2, and -3. But notice here, we list them in ascending order from least to greatest. We always list elements in the domain and range from least to greatest, no matter what order they appear, okay, before we write them. So notice that our range went 2, 1, 0, -1, -2, and -3. We would not write that this way. So we would not write it 2, 1, 0, -1, -2, -3. We wouldn't write it that way. Okay, we write it from least to greatest, always. Our domain or range, least to greatest. Okay, domain and range. Now, let's look at what makes a relation a function. A relation in which the first coordinate is never repeated is called a function. In a function, there is only one output for each input. So each element of the domain, or each x, is mapped to exactly one element in the range. Okay, so each x only goes to one y. We don't have duplicate x's going to two different elements. Although a single input is in a function cannot be mapped to more than one output, two or more inputs can be mapped to the same output. So here we see that 2 gets mapped to A, it gets mapped to B, and it gets mapped to C. If I were to draw that as a ordered pairs, 2 goes to A, and then 2 goes to B, and then 2 goes to C. So notice here I have 1x, or 2, going to different y's. 2 goes to A, 2 goes to B, and 2 goes to C. That is not a function. That is not a function. Okay. For the relation to be a function, each x only has to go to one y. In other words, you don't have x's repeated. Here, I have 2 repeated 3 times. But now, it's okay though. So it's okay to have different x's that have the same y. So here, A goes to 2 in this example, B goes to 2, and then C goes to 2. So that's okay, because each x only goes to one y. So we only have, none of the x's are repeated. They're all different. Okay, so that is a function. That's a function. That relation is a function. And then let's look at some examples. Determine whether each relation is a function. From items in a store to prices on a certain day. Well, let's certainly hope it's a function, because if you or mom or dad goes and you buy a box of cereal, you go in the store and buy a box of cereal, and it costs $2. And then you go back in the store 5 minutes later, same box, if it costs $2.50, you're going to raise eyebrows. Something is wrong there. Hey, wait a minute. I just spent $2 for that box of Cheerios. Why is it $2.50? Okay. So that would not be a, so that would be a, so that would be a function. As long as one box of Cheerio only goes to one price, that would be a function. Okay, you certainly hope that would be a function. You would not want the same box of Cheerio to go to 2 different prices. So each item only goes to one price. That's a function. But how about apples? So here you have an apple. You have a red apple, a green apple, and a yellow apple. So you have a red apple, a green apple, and a yellow apple. So an apple is red, an apple is green, and an apple is yellow. Okay, that relation is not a function. You have the same x, a, going to different colors. That relation would not be a function. Okay. Let's look at the next example. Shoe size to prices. So here, size 7 has a price of $35. Size 8 has a price of $35. And size 9 has a price of $35. That relation is a function because you only have one x. None of the x's are repeated, okay, even though they go to the same price. That relation is a function. From items in a grocery cart to the total cost of the items in the cart. Well, let's say here, customer A, they have, let's see here, they have 15 items in their grocery cart, and it costs, like, say, $50. And then, so that's customer A. And then customer B, they also have 15 items in their grocery cart, and it costs, let's say here, $75. So you have 15 going to 50, and you have 15 going to 75. That relation is not a function. You have the same x going to 2 different y's. Oops, the same x going to 2 different y's. That relation is not a function. Not a function. Now, There's a very easy way to determine by looking at a graph whether or not a relation is a function. And we have something called the vertical line test. And basically the vertical line test works like this. If you take a graph and you draw a vertical line, a line that goes up or down, and if it only crosses the graph in one spot, then that relation is a function. In other words, each x only goes to one y. So it passes the vertical line test. Each x only goes to one y. Let's look at this one here. So if I draw a vertical line, okay, notice here, so that's an x. That would be like x. So let's say this could be the point x is 2 and y is 2, and this could be the point x is 2 and y is negative 2. Okay, but you can see that one x, 2, goes to two different y's. Okay, two different y's. That relation is not a function. Very easy way to tell by looking at a graph whether or not a relation is a function if it passes the vertical line test. Let's look at the next example. So here we have, here we have this graph, and we'll draw a vertical line. And if that vertical line only crosses in one spot, that relation is a function, and it is. It's a function. That relation is a function. Here's another one. Okay, so here I have, so this is a graph, and we want to know, is that relation a function? Well, if I draw a vertical line, like at 1, okay, so this would be the point 1 and 1, and they gave us that, and that's the point 1 and negative 2. So notice we have 1xy going to, or 1x1 going to two different y's, 1 and negative 2. That relation is not a function. It does not pass the vertical line test. And then finally, let's see here, if I draw a vertical line anywhere, well, that relation is a function because that vertical line only crosses a graph in one spot. And then finally, the last one here. So again, so if it passes the vertical line test, that's good there. But if I draw a vertical line right here, notice that that vertical line has two y's associated with it. So here they say that's the point 1 and 2, and this is the point 1 and negative 2. So that relation is not a function because you have the same x going to two different y's, 2 and negative 2. Okay, so that's video 1, and then we'll do video 2.